Hello. In this session, let us study the rules to test the divisibility by different numbers. To say a number is divisible by 2, the only rule here is that the last digit of the number must be either 0 or even number. Last digit must be 0 or even. Say for example, I have a number 64. Now since the last digit of this number, that is 4, is an even number, you can say that this number is divisible by 2. Suppose I give you a number 1258634. Now because the last digit of this number is an even number, you can directly say that this number is divisible by 2. You don't have to exactly do the division and check if the quotient is a whole number or if the remainder is 0 or do those steps. You just have to see if the last digit is an even number or 0. Suppose if I give you a number, say 1560, because this is 0, the last digit is 0 here, you can also say that in this case the number 1560 is divisible by 2. Now how do you say a number is divisible by 3? You say that a number is divisible by 3 when the sum of digits of the number is divisible by 3. Like say for example, I have a number 156. Now what are the sum of the digits 1 plus 5 plus 6? That is 12, isn't it? Now 12 is divisible by 3, isn't it? 3 times 4 is 12. So 12 is divisible by 3, and hence you can say that 156 is divisible by 3. Suppose I give you a number, say something like 1, 2, say 3, 3. Now if I'm going to add these digits, that is 1 plus 2 plus 3 plus 3, when you add these digits, what do you get? This is 3, 3, this is 9. And because 9 is exactly divisible by 3, you can say that this number 1233 is divisible by 3. Right? Now let us see the divisibility test for 4. You can say that a number, when the number is made by the last two digits of the number is divisible by 4, then that whole number is divisible by 4. Let us say for example, you have say something like say 64 say 28. Now what are the last two digits? Last two digits are 28, that is 28. Now 28, is it divisible by 4? Yes, because 4 times 7 is 28. So because 28 is divisible by 4, you say that this number, the whole number, that is 6428, is divisible by 4. That is, when you are dividing this number by 4, you get a 0 remainder with a whole number as quotient. Yes, suppose you have a number, say something like okay, let me give you an example. Whenever you have two zeros or more than two zeros towards the end of the number, say something like say 4300. Now what do you do in this case? Because you have two zeros here or more than two zeros, then you can directly say that the number is divisible by 4. Anything, whenever you have two or more zeros towards the end of the number, you can say that the number is divisible by 4. Or when the last two digits of the number is divisible by 4, you can say that the number is divisible by 4. Like say 4300, in this case, because the last two digits are zeros, you can say that the number is divisible by 4. Suppose if I give you a number like say 153000, because there are three zeros towards the end of it, you can say yes, this number is divisible by 4. You can verify it if the statement is right or wrong by just dividing this number by 4. Let us say I am dividing 4300 by 4. When I am dividing it by 4, 4 times 1 is 4. That will give you 3. Then you bring down, you put a 0 and bring down this, and this will be 4 sevens is 28, and then you have 2 and bring down the 0. 4 5s are 20. That will leave you with a 0 remainder with 1075 as the quotient, which is a whole number. Remainder is 0. So because these two conditions are satisfied, you can say that the number is divisible by 4. So instead of doing all these tedious steps, the only simple step is to see if it ends with two zeros or more than two zeros. If it does, then the number is exactly divisible by 4, or otherwise if the last two digits are divisible by 4, then the number is divisible by 4. Now when do you say a number is divisible by 5? It is divisible by 5 only if the last digit of the number ends with either a 0 or 5, right? Last digit is either a 0 or 5. If it is 0 or 5, you can say that the number is divisible by 5. Like say in this case I told you the same thing. If the last digit is 0, then the number is divisible by 2, and the number is divisible by 5 also. And if the last digit is 5, then the number is exactly divisible by 5. Like say for example, you have any number, say like 135, 195 or 4350, any such number. This last digit, if it is 5 or 0, you can say that the number is divisible by 5. Okay. So when do you say now a number is divisible by 6? You say a number is divisible by 6 when it is divisible by both 3 and 2. So when do you say a number is divisible by 2? When the last digit is 0 or even. When do you say a number is divisible by 3? When the sum of digits is divisible by 3, you say that the number is divisible by 3. So when these two conditions are satisfied, then you say that the number is divisible by 6. Like say for example, you have a number like say 720, right? Now because this is 0, it ends with 0, the last digit is 0, this number is exactly divisible by 2. So that condition is satisfied. Now what is 7 plus 2 plus 0? 7 plus 2 plus 0 is 9. Because this 9 is exactly divisible by 3. So this 720 is divisible by 3 as well. Now because these two conditions are satisfied, you can say 720 is divisible by 6 as well. Understand? Suppose I give you another example, say like say 40. Now because this last digit is 0, you can say that this number is divisible by 2. What is the sum of the digits? 1 plus 4 plus 4 plus 0. This is 9. 9 is exactly divisible by 3. So this number 1440 is divisible by 3 as well. So it is divisible by both 2 and 3. That implies the number is divisible by 6. Okay. How do you say a number is divisible by 7? Now this appears to be little complicated. In general, whenever we come across this question, like whether you test whether a number is divisible by 7 or not, it is quite easier if you directly divide it and check it. But otherwise, we also have a technique to understand that if the difference between twice the digit at one's place and the number formed by other digits is either 0 or a multiple of 7. Suppose I give you a number, say 658, right? Now what is what is a number in units place? It is 8. So I want two times the number in units place. What is 2 times the number in units place? That is 2 into 8, which is 16. Now I want the difference of the remaining number formed by the remaining digits. What is a number formed by remaining digits? It is 65. Now I want to subtract this number 2 times the units place, that is 16. What is 65 minus 16? That gives you 49. Because 49 is exactly divisible by 7, you can say that this number 658 is exactly divisible by 7. Understand? So this appears little cumbersome, but this is also quite an easy technique. It's up to the student's choice as to what technique they want to employ to check whether the number is divisible by 7 or not. Now if I say the number, if I have to test the number is divisible by 8 or not, when the number made by the last 3 digits of the number is divisible by 8, then the number is also divisible by 8. The last 3 digits, suppose I give you a number like say 2256. What are the last 3 digits? 256. Is this number 256 divisible by 8? Yes, you know that, because 256, when you are dividing it by 8, 8 times 3 is 24, this is 16, and 8 times 2 is 16. That will leave you with a 0 remainder and a whole number as a quotient. So 256 is divisible by 8, so you can say this number 2256 is divisible by 8. So to check the divisibility of a number by 8, you have to check if the last 3 digits formed by the number are divisible by 8 or not. Suppose I give you a question like, suppose say this, we have the 4, say 4 3 6 2 0 0 0. Now what will you do? Now last 3 digits are zeros, so because the last 3 digits are zeros, then this number is definitely divisible by 8. That you can directly say that this number is divisible by 8 when the last 3 digits are zeros in the given number, right? Either if they are exactly divisible or if they are zeros, you can directly say that the number is divisible by 8. And when the sum of the digits of a number is divisible by 9, you say that the number is divisible by 9. So you must have sum of digits of the number must be divisible by 9. Like say for example, I have say 4 3 5 and 6. Now what is the sum of these digits? 4 plus 3 plus 5 plus 6. When you add this, it will be okay, this will be 18. Now because 18 is divisible by 9, you can say that this number 4356 is divisible by 9. So the divisibility test for 3 and 9 are almost similar. The sum of digits must be divisible by 3 in order to say that the number is divisible by 3, and the sum of digits must be divisible by 9 in order to say that the number is divisible by 9, right? And when you say a number is divisible by 10, you say a number is divisible by 10 when it ends with 0, or that when the last digit is 0, you say that the number is divisible by 10, right? So this is the test of divisibility up to 10 up to numbers 10.